Okay. So, very good afternoon, students. Sorry for the delay due to some technical issue. It got delayed, but no issues. We'll begin with our class. Okay. So, in our previous class, we discussed about what? We discussed about the arithmetical geometric series, right? And we also solved one problem based on that. And we saw a general formula to find the sum of that arithmetical geometric series. But as it's such a long formula, what we have done is, wait a minute. Okay. What we have done, we have used some certain steps to solve it, right? Well, so in our today's class, what we'll do, we'll solve some more problem on arithmetical geometric series or some series of similar kind, and we'll see what are sigma notation and properties of sigma notation, and we'll also see some special series, okay, and method of difference. What is this method of difference and all, and some problems based on it. Okay, so this will be the content of our today's class. Fine. Well, okay. So without wasting much of our time, let's begin. Well, here we have some recall questions, okay. So let me see how many of you remember the things that we learned in the last class. So just please read the question, and for the Zoom students, I'll be launching the poll. Please to respond in the poll, and the YouTube students, please to respond in the chat box, okay? Right? Well, so Zoom students, please to respond your answer in the chat box. So question is, if A, G, H are respectively AM, GM, HM, between A and B both being positive, then which among the following is correct one? Answer me in the chat box. Come on. This thing we studied in our last class, right? Relationship between AM, GM and HM. In that concept, we studied it. Tell me. Answer, please give your answers in the chat box. Okay. Come on, quick. It's easy one. Kripa and also YouTube students, do answer in the chat box. Okay. Okay. So if A, G, H are respectively AM, GM, HM between A and B, both A and B being positive, then our answer will be what? G square is equal to AH. So this is the relation between arithmetic mean, geometric mean, and harmonic mean. Okay. Square of the geometric mean will be equal to product of arithmetic mean and the harmonic mean. Okay. So is it clear to you all? Any doubt in this? Fine then. So there's a next question here. Next is, which of the following is arithmetico-geometric series? Well, what is arithmetico-geometric series? It is a series formed by taking the product of corresponding elements of AP and GP. Correct? You take first term of AP and first term of GP, multiply it, you will get one term, plus second term of AP, second term of GP, multiply it, plus, so what, if you continue this procedure, whatever series that you get here, that we call it as what? Arithmetical geometric mean. So among this, which one is the arithmetical geometric series? Yes. Tell me. Answer me in the chat box quickly. Just look at the pattern and answer me in the chat box. Okay. Fine then. Here you observe, this is 1 into 1. And the second term can be written as 2 into 2. Third term can be written as 3 into 3, plus so on, right? If you observe here, These first terms are what? First terms are on in AP. That's fine for us. Look at the second terms. These are all the same. 1, 2, 3. Are they in GP? No, right? Again, they are in AP. So this is not a arithmetic geometric series. And let's come to the next option. The next option is 4 plus 16 plus 48, so on. Correct? First term, how can we write? We can write first term as 2 into 2, correct? Plus second term can be written as 4 into 2 square. Right? 4 into, it will be 4, 16 plus third term, that is 48. It can be written as 6 into 2 cube, right? 2 cube is nothing but 8. 8 into 6 is 48. Plus, similarly, we can write the fourth and fifth terms. Now observe the pattern here. You can observe this first terms 2, 4, 6. This all are in AP, right? Why are they in AP? Tell me. Why am I saying 2, 4, 6? So on are in AP? Because these are the terms with a common difference 2. Correct? Yeah. Now look at the second terms. The second terms are what? 2, 2 square, 2 cube, so on, right? Now tell me which progression are they? Yes. Tell me the progression. They are in GP, right? GP with a common ratio is equal to 2. Isn't it? So take common ratio. You will get take a ratio of consecutive terms. You will get same ratio. So this 2, 2 square, 2 cube, these are in GP. So as this is the combination of AP and GP, we can say this series is a arithmetico-geometric series. Okay. So is it clear to you all how we have concluded this as an arithmetico-geometric series? Any doubt in this? If you have any doubt, so please pinch me in the text box, okay? Well, so coming to the option 3, you can answer it. It's an AP. AP with a common difference 3, right? Between each consecutive term, the difference is 3. And coming to the last one, it's a GP with a common ratio 2. So these are purely AP, purely GP. So the only option that we left with is option 2. So it's arithmetico-geometric series. So is it clear to you all? Any doubt in this? Yeah. Let me know in the chat box if you have any doubt. Okay, cool then. If there is no doubt, we'll move ahead with the next one, okay? Fine. Next is the homework question. This question I have given for the homework in the last class, right? How many of you have done it? I have got the answer to in the last class by Jenny Chutridurga. So anybody else who have done this? Yes. Well, if you have done this, the answer of this question is option C, okay? How we have got option C? Let's see it, okay? So if you have done, then cross-verify your answer. So the correct answer will be option C, that is A plus B by AB, okay? Well, how we got option C? Let's see it. What is the question? Question is, if A1, A2 be two arithmetic mean and G1, G2 be two geometric mean between A and B, then A1 plus A2 divided by G1 into G2 is equal to, yeah? What they have said? They said that there is A and B and A1 and A2 is a arithmetic mean between A and B, right? Now how to find a difference, tell me? Common difference when n arithmetic means are given to us. We have seen that formula in the previous classes, right? Common difference when n arithmetic means are given to us. What is the formula? Yes, B is equal to B minus A divided by n plus 1, right? Correct? Here what is n? N is nothing but number of arithmetic means that we have between A and B. Here we have 2, so n will be 2. Therefore, difference will be equal to B minus A divided by 3. Fine. So what will be A1 equal to? A1 equal to A plus D, right? So it is equal to, because it's the second term, first term is A, second term will be A plus D. So A plus D is nothing but B minus A divided by 3. Fine. Similarly, what will be A2 equal to? A2 will be equal to A plus 2D. It will be equal to what? A plus 2 into B minus A divided by 3. Fine. Now, they have also said that G1 and G2 are the two geometric mean between A and B. So, these are the A and B. We have two geometric mean, G1 and G2 between them. Fine. And now, tell me what will be the common ratio here if we have two geometric means between A and B? Yes. Even this thing we have seen in the previous classes, right? When we have n geometric mean between A and B, what is the common ratio? What are the value of the terms? Isn't it? So R will be equal to what? It will be equal to B by A whole raised to 1 by n plus 1. Here n is equal to 2 as we have two geometric means. So this will be equal to B by A whole raised to 1 by 3. Okay. So what will be G1 equal to in this case? G1 will be equal to A into R, right? It's a second term. So A into R is nothing but B by A whole raised to 1 by 3. And G2 will be equal to A into R square. So it will be equal to A into B by A whole raised to 2 by 3. Okay. Now what do we want? We want value of A1 plus A2 divided by G1 into G2, right? Correct? We want A1 plus A2 divided by G1 into G2. So observe here, what is A1? This is the value of A1. This is the value of A2. Add this both. What we will get? When we add those both, we will get 2A plus is B minus A by 3 plus 2 into B minus A by 3. It's gonna be 3 into B minus A by 3 whole divided by G1 into G2. Just multiply this both. When we multiply those both terms, we will get A squared into B by A. Okay. Now just simplify it. This 3 get cancelled. In the numerator, we will get A plus B. And in the denominator, these both terms get cancelled. A into B. Okay. So the right option is option C. Correct? So is this clear to you all? Any doubt in this problem? Tell me. Any doubt in this? Okay. If you have any doubt, please do respond in the chat box. Okay. Fine. Well, if there is no doubt, we'll go to the next one. Fine. Next is another homework question I had given to you all. So we solved one arithmetical geometric mean series question in the previous class, right? At the end, and I had given one question for the homework. So have you all done it? Okay, if you all done it, then well and good. If you haven't, no issues. We'll continue with this problem. So what is the series they have given? They have given that find the sum of the series 4 minus 9x plus 16x squared minus 25x cubed plus 36x raised to 4 minus so on, right? Sum of this series. Now observe this series and tell me whether the series is in AP, GP or AGP, as it's arithmetical geometric progression series. So tell me which of this, what kind of series is it? Tell me whether it is one among this or no. Yes or no? That's all. Tell me whether this series is one among these three or no. Yes. JP Bhandari, Kripa, do answer in the chat box, okay? Well, when you observe the series, what are the extremes that you find? Extremes that you find are 1 minus x squared minus x cubed, so on. You can observe that this is in GP with a common ratio is equal to minus x. But when you observe the coefficient of this x terms, that is 4, 9, 16, these are neither AP nor GP, correct? Here the common difference is not same. The difference here is 5 and here the difference is 7 and so on. It's not same. It's changing, right? So these are not AP. So this is neither a AP, GP or arithmetic or geometric series, okay? So the question might arise, right, ma'am, how to solve it? We know how to solve series only of this kind. Well, we can solve this kind of series using the same method that we used for arithmetic or geometric series, okay? What we have done in solving arithmetic or geometric series? Tell me. See, in solving arithmetic or geometric series, we followed 4 steps, right? What were the steps? First, write down the Sn, then multiply Sn with R. We have to, okay, I'll just rub it. Multiply Sn with common ratio of the geometric progression that we'll have in the series. And then take the difference of that both, that is Sn minus Rsn. Now, if this Sn minus Rsn consists of any geometric terms, then we'll solve using formula of GP, right? Then we solve it using formula of GP. If no geometric terms involved, what we have to do? I said we have to repeat the steps. We have to repeat the steps. Correct? So this was the procedure that we applied for our previous problem, right? So same thing will apply here. So let's see how to solve it. Okay. Fine. Let me grab it. Okay. Let me write a Sn. So Sn is equal to 4 minus 9x plus 16x squared minus 25x cubed plus so on, right? Correct. Now, the geometric series here is, wait, the geometric progression here is what? 1 minus x squared minus x cubed, so on, right? With r is equal to minus x. So multiply this xn with minus x. So what we will get? We will get minus xsn, that is equal to minus 4x. Second term is minus 9x. Multiply it with minus x. It's gonna be plus 9x squared. Third term gonna be minus 16x cubed plus so on as it is. Okay. So this is the second step that we have to do. Now what we have to do in the third step? Yes. Tell me what we have to do in the third step. Here we have to take difference of this both. So take the difference of Sn and minus x Sn. What it will be? It will be Sn minus of minus x Sn will be plus x Sn equal to 4 minus 0 as it is minus 9x minus of minus 4x will be what? Minus 5x. Then subtract this both terms. Subtract this terms. Subtract this terms. So when you subtract these two terms, that is 16x squared minus 9x squared, we will get plus 7x squared. And here we will get minus 9x cubed plus so on, right? Correct? Now observe this. Are we able to find any geometric progression here? Yes. It is 5x, 7x squared minus 9x cubed. No, right? But what can we find here? We can find that this is nothing but it's a arithmetico-geometric series, right? Just observe here. Leave this 4, okay? Just consider this terms. Just observe here. It's an arithmetico-geometric progression where common difference is what? 2. Here we have 5 plus 2, 7 plus 2, 9. So common difference of AP is 2. And we have a geometric progression that is minus x squared minus x cubed, where common ratio is equal to minus x. Correct? Yes. So as we are unable to find a geometric series here, we'll repeat the procedure. We'll repeat the same procedure again. Okay. So have you understood till now this point? We have solved till this step. Okay. Now in the next step, what happened? We not found any geometric terms. So no geometric terms involved. So we are repeating the procedure now. So what is the repeating the procedure? Multiplying this by common ratio again. So this is nothing but we can write it as Sn into 1 plus x, right? And remaining terms as it is 4 minus 5x plus 7x squared minus 9x cubed plus so on. So multiply this with the common ratio, that is minus x, correct? Okay. So when we multiply, we will get Sn into 1 plus x equal to 4x, multiply 4 with x, 4x minus, multiply this with the minus x. So this is minus 4x, right? It's gonna be plus 5x squared, multiply third term with the minus 6, it's gonna be minus 7x cubed plus so on, right? Correct? Now what we have to do? We have to take, I'll just try to write it here so that we don't pull it to the next page. Okay. Now just take a difference of this both. Now we'll take difference of these two terms, this and this, right? So it's gonna be what? It's gonna be Sn 1 plus x minus Sn 1 plus x into x. That's gonna be equal to 4 as it is minus 5x. Minus of minus 4x will be what? Yeah. It will be plus x, right? Correct? Now, next term. Difference of these two terms. 7x squared minus 5x squared will be what? Plus 2x squared. Here, minus x cube minus of minus 7x cube will be minus 2x cube. Okay? So these are the terms. Fine. Now, let me write same thing in the next page. Okay. This. Previous one. Observe here. Here I can take, just observe this. Sn 1 plus 6 and Sn 1 plus 6 is common term. So what will I get? I will get Sn 1 plus x into 1 plus x equal to, I have 4 plus x plus 2x squared, 4 plus x plus 2x squared minus 2x cube plus so on, right? Now observe, leave this 4 plus x. Observe remaining terms, these terms, okay? If you want me to write, I'll write one more term. The one more term will be 2x raised to 4 here. Observe these terms. I can take 2x common here, 2x square common. So it's gonna be 1 minus x plus x squared, so on. Okay, minus plus so on. Observe these terms inside the bracket. What kind of series is it? Tell me. What kind of series is 1 minus x plus x squared? Yes. Tell me. Jamie Ballard, tell me what kind of series is it? 1 minus x plus x squared, so on. It's minus x, right? Yeah. Okay. Fine. So what kind of series is it? 1 minus x plus x squared, so on. Yes. You do, guys, as well as students. Tell me. Is it AB, GP, or HP? Tell me. Is it an arithmetic series, geometric series, or a AGP? Just answer me in the chat box. It is GP, right? Correct? GP with the common ratio is equal to minus x. Correct? Now, 4 plus x I keep as it is. This is gonna be Sn into 1 plus x whole square. Correct? Plus 2x square. Tell me what is the sum of the infinite terms in GP? Okay. Here x is less than 1. Assume. Fine. If it's greater than 1, the sum will be infinite. We can't find it. So common ratio is mod x, mod r is less than 1 in this case. Fine. So what will be the sum in that case? What is the sum of the infinite terms? Tell me. Very good, Jamie Ballari. Yes, your answer is correct. It's GP. So sum of the infinite terms, S infinity is equal to, it's A upon 1 minus R, right? Correct? The same thing we will make, we'll use it here. So it's gonna be what? It will be A is what? A is 1 here. 1 divided by 1 minus R is what? R is equal to minus x, right? So minus x. Correct? Sum of this infinite terms will be this. Now we will get, so Sn will be equal to what? 4 plus x. I'll just shift this 1 plus x square on other side. It's gonna be 1 plus x whole square plus 2x square divided by 1 plus x whole cube. Okay. So this will be the sum of the given series. Okay. So this was the series given to us. So sum of this series will be Sn, whose value we found it, right? So is it clear to you? Any doubt in this question? I'll just briefly go through this question again. First, what we have done, we have seen that this series is neither in AP, GP or AG, but we followed the method, same method, which we followed in the AG. We wrote the Sn, first step. Second step is we multiplied the Sn with the common ratio. We got this. In third step, what we have done, we subtracted these two terms, Sn minus of minus x Sn. We got this. Correct? And we have found that it is AGP. Then again we repeated the procedure as these bracket terms are not in geometric series. Again, what we have done, we consider this series, we multiplied it with the common ratio, that is minus x. Is very good. It's minus x. Okay. So this is gonna be plus, right? Yes. Fine. So we multiplied it with a common ratio. And again, we subtracted these terms. We got this series. When we subtracted, we got a geometric series, right? After that, we computed it using this formula and we found the value of Sn. So is it clear to you? Jamie Ballari, is this clear to you, this question? Any doubt in this question? Let me know in the chat box. Yes. Okay, then if there is no doubt in this question, we'll move to the next one. Okay, next. So next, it's a one more series. Try to find some of this. Okay, it's a homework question. Try it at home. It's same kind of. It's a, when you find some of this, it will be AGP. Okay, arithmetico geometric series. Fine. use the same procedure and try to find sum of this. Okay. Well, next. Next that we're gonna learn is sigma notation. Well, this is a sigma notation. Okay. So let's see what is the sigma notation. We make use of sigma notation to represent the sum. Okay. To represent sum. Let me write it properly. So we make use of the sigma notation to represent the sum. Suppose we have a sum of the series like 1 plus 2 plus 3 plus so on up to n, okay? Every time we can't write all the terms, right? So we make use of this symbol to represent the sum of this. So how do we write it? We write it as summation k varying from 1 to n, okay? What is this? Observe here. When you substitute k is equal to 1, you will get 1 plus. It's varying from 1 to n, right? After 1, which is the term that we get? 2. So it will be plus 2, plus 3, so on up towards the last term. Last term is n, okay? This is how we represent the sum of the terms, right? Summation is the, sigma is the notation. It's also in a summation. It used to represent the sum of the terms. So is it clear to you all what is sigma notation? Sum of the terms. Fine. Okay then. Since it is clear, we'll go to next part. That is okay. Yeah. There's some questions here. The next part is expand the sigma notation into series. Yes. They're given the summation. We have to expand it. How do we expand? We keep on substituting for one values and we add them. Right? Tell me what we will get here when we expand it. So this will be equal to, first if term is what? I is equal to 0. Substitute I is equal to 0 here. What you will get? 1. Plus second term is what? I is equal to 1, right? After 0, you will get 1, 2, 3. After, remember, this whatever summation I is equal to 0 to n, whatever we write, that will be positive integers, okay? Those will be always non-negative terms, right? Non-negative integers. So next is what? Next is 1. So when you substitute 1 here, you will get 2 plus 1, that is 3, plus substitute third term, that is 2, and substitute 2 here, you will get 2 into 2, 4, 4 plus 1, 5, okay? Plus so on up to n terms is it. So when you replace I by n, what will you get? You will get 2n plus 1, right? Yes. So this is the expanded form of our series, okay? So is it clear to you? Any doubt in this? Now try to find this. Let me know. Let me know the general term of the sequence. General term is they are given the series here. No, it's not series. They are given a sequence here. You have to find the nth term. So general term, by general term they mean nth term, okay? Find nth term of this sequence. Let me know. So in general term we have one variable. That's all. What will be the Tn here? Yes. Answer me in the chat box. Observe the pattern and answer me in the chat box what will be the Tn. Let me know. We'll answer in the chat box, okay? I'll give 30 seconds to you all. Say around 20 seconds. And let me know who will answer in the chat box. Come on. Just observe here. Okay. Time is up. No issues. Just observe here. First, how it is varying. It is 2, 4, 6. How it is varying? It is an AP with a common difference for 2, right? Yes. 2, 4, 6, so on. I can write as what? 2 into n, correct? It is an what? Terms of even number. So 2 into n. Now, how the product, it's a product of two terms, 2 and here are 3. Now, how this 3, 9, 27 are varying? Tell me. Observe here. 3, next term is 9. First term is 3. Second term is 9. How can we write 9? We can write 9 as 3 square, right? Third term is 27. I can write 27 as 3 cube, correct? If I continue this till nth term, what will I get? I will get 3 raised to n, correct? So Tn will be what? Tn will be equal to 2 into n into 3 raised to n. So is it clear to you all? Have you understood this? How we found the nth term of the sequence? Well, remember, it's very important to know how to find the nth term of the sequence, right? Because using that nth term, we will find the sum in our next slides. We will see how to do that. But please do remember them, okay? Like, understand how to find nth term of the sequence. Just observe the pattern. Observe the pattern. And according to the pattern, write down the terms, okay? That's how we find the nth term. So is it clear to you all? Okay. So if this is clear, we'll go to the next slide. Next, properties of the sigma notation, okay? Let's see. So sigma of r is equal to 1 to n, AR plus or minus BR will be equal to, this we read as summation r is equal to 1 to n AR plus or minus summation r is equal to 1 to n BR. Okay. Remember the sigma, it is read as summation. Fine. Okay. For example, I have 1 plus 2 plus 3, so on, right? I can write it as 1 plus 3 plus 5 plus so on, plus 2 plus 4 plus 6, so on, right? Again, it will give us the sum of the natural numbers itself. So if I want to write this in summation, how will I write? Summation. Nth term here will be what? 2n plus 1, okay? This will be the nth term. Okay. 2n minus 1, I will make it. So when n is equal to 1, you substitute, you should get first term, right? So from n is equal to 1 to infinity. Because terms are not ending here. They are just moving infinite. Plus this I can write as what? Summation n is equal to 1 to infinity 2n. Correct? So you can observe here, I am writing summation of sum of this as summation of even odd numbers plus summation of even numbers, right? So we can split the summation. If we have something like this, we can split it as summation of AR from R is equal to 1 to n plus or minus summation of BR from R is equal to 1 to n. Okay. Well, second, if we have any constant term inside the summation, we can take it outside the summation. Here K is constant. If we have any constant term inside the summation, we can take it outside the summation. For example, we have 2n square, n is equal to 1 to infinity. Then I can write it as 2 into summation of n is equal to 1 to infinity n square. It's obvious, right? If you expand it, what you will get? You will get 2 into 1 plus 2 into 1 square plus 2 into 1, 2 square, 2 square, 3 square, so on, right? Here you can take 2 common, so it's gonna be 1 plus 2 square plus 3 square, so on. This is nothing but this summation, isn't it? Okay. So similarly, in the third case, summation of k can be written as n into k. It's a constant term. So what actually k is a constant. From r is equal to 1 to n means what? We are running k from r is equal to 1 to n. Means we are adding it just k plus k plus k, so on up to what? Up to n terms, right? So up to n times. N times what we are doing? We are adding it. So when we are adding k n times, what we will get? We will get n into k, isn't it? So summation of k can be written as what? N into k. So is this clear to you all? Any doubt in this? Yes. Let me know if you have any doubt in this in the chat box. Okay. Okay, fine. If there is no doubt, then we'll go to the next part. Next. Some special series, okay? These are some special series. Well, these are very important series, right? You need to remember them. If I ask what is summation of r squared from r is equal to 1 to n, you must be able to tell that. If I ask summation of r cubed, then you should be able to tell that. Even though I asked it when you're sleeping, you must be able to tell that. These are that important because this summation will help us to find value of so many other series. Fine? So please do remember them. Now here we have summation of r is equal to 1 to n is equal to n into n plus 1 by 2. What is summation of r? It's nothing but sum of first and natural numbers, right? Replace r by 1 plus second term is 2. Third is 3, and so on up to n. So sum of first and natural numbers will be equal to n into n plus 1 by 2. How actually we got this n into n plus 1 by 2? You might be wondering, right? Well, you can observe this is nothing but AP with the first term is equal to 1, common difference is equal to 1, right? Just make use of the sum of the n terms of AP formula, you will get this, right? You don't need to derive that or all, just remember it, that's more than enough. Second is summation of r is equal to 1 to n r square. So r is equal to 1 to n r square will mean 1 square plus 2 square, 3 square, so on up to n square, right? So that will be equal to n into n plus 1 into 2n plus 1 divided by 6. So sum of the first n, square of first n natural number will be equal to n into n plus 1 into 2n plus 1 divided by 6. Remember it. Today you will go and practice this all summations, okay? Well, next is summation of r cube from r is equal to 1 to n. So this will be equal to n square into n plus 1 whole square divided by 4, okay? So sum of the cubes of first n natural number will be this. Now you might be thinking, ma'am, how actually this we solved using AB, we got the sum. What about the other two series? How actually we found the value of it? Well, we can find the value of it using mathematical induction. It's a fourth chapter that you study in the MCRT. Using that, we can do that. These both are equivalent, okay? This is equal to this, and summation of r cube is equal to this value. Fine. Proof is not needed to you all, so we are not discussing it here. But values you have to remember. Okay. Next, there are some more. So what is this? Sum of fourth power of first n natural numbers. Okay, that will be equal to this n divided by 30 into n plus 1 into 2n plus 1 into 3n square plus 3n minus 1. Okay. And sum of first n odd number natural number will be equal to n square. Sum of first n even natural number will be equal to n into n plus 1. Okay. Please remember this all again. Well then. So is it clear to you all? These formulas? The only thing you have to do here is to remember these formulas. Okay. Any doubt in this? Well then, if there is no doubt, we'll go to the next section. Fine. Next. So in the next section, there's a question. Find the sum of n terms of the series whose nth term is n into n plus 1, n plus 4. Okay. If nth term is this, what will be the kth term? Tell me. Tk will be equal to what? Kth term will be equal to, just replace by n by k, right? It will be k into k plus 1 into k plus 4, correct? They're asking us to find the sum of n terms, asking us to find Sn. So Sn will be equal to what? T1 plus T2 plus so on up to Tn, right? So I can write Sn is equal to summation from k is equal to 1 to n Tk, correct? Just replace k by 1, 2, 3, 4. You will get this itself. Correct? Okay. Now, summation k is equal to 1 to n, replace tk1. That is k into k plus 1 into k plus 4. Okay. So what will you get? You will get k into 1 to n. Multiply these terms. You will get, this is nothing but k square plus 4k plus k plus 4, right? Okay, I'll directly write it as 5k plus 4. Correct? If you multiply this k again, this outside k, you will get summation k is equal to 1 to n k cube plus 5k plus 4k, right? Correct. Now, according to the property of our summation, what can I do here? I can write this as summation k is equal to 1 to n k cube plus 5 is constant. I'm taking it outside. Summation k is equal to 1 to n k plus, okay, this is only 4. This is not 4k. Plus summation 4 from k is equal to 1 to n, right? This is what I can write. I just made use of property of summation here. Okay, taking constant outside. If constant is multiplied to a term variable, we can take it outside. Now, yes, it's 5k squared, madam. Yeah. Sorry, it's 5k squared. Thank you, Jeremy Badari. It's 5k squared. Correct. Now, what we have to do? Just to make use of our formulas directly here. What is the sum of first n terms of first n cubes of natural number? It's nothing but, okay, correct. I'm sorry. It's 4k. Very good, Jamie Badari. Thank you. So next we will get, sorry, I'll add the page. Okay. Let me snap this. Take me to. Okay. Well, this we have, right? So this we can equate to, what is sum of the first cubes of natural numbers? It is nothing but n into n square into n plus 1 whole square divided by 4, right? This we have seen in our previous slides, okay? Plus 5 into sum of the square of first n natural numbers will be what? It will be equal to n into n plus 1 into 2n plus 1 divided by 6 plus 4 I take common, constant. Summation of k from k is equal to 1 to n will be, that is sum of first n natural numbers will be n into n plus 1 divided by 2. Okay. So this is nothing but, this represents the sum of our summation of these terms. Okay. Sum of the n terms of the series whose nth term is this. So this will be sum of those n terms. Okay. Is it clear to you? Any doubt in this question? Yeah. Anybody? Any doubt? Just to make use of the formulas that we discussed in our previous class. So previous slide, this itself I am making. Here there are, I used k there, that's all. Sum of first n natural number is this. Sum of first n first square of first n natural number is this, and cube of first n natural number is this. Those three things only I have used here. Okay. So is it clear to you all? No doubt, right? If no doubt, then well and good. We have next one more question. Well, try to solve this question. Try to solve this question. Let me see. Find the sum of the series 1 into n minus 2 into n minus 1 plus 3 into n minus 2 plus so on up to n into 1. Now, to find any sum of the series, first we have to do using summation. If you want to find the sum of the series, we have to find the rth term, right, or kth term. Some general term we have to find, right? So now let's try to find the general term. Observe the first term here. How this first term is varying? It's 1, 2, 3, so on, right? It's varying like this. Okay, this is plus. So on. It's varying like this. Okay. First term is varying as 1, 2, 3, so on. So kth term will be what? K. Correct? We got it. Now observe how the second term is varying. That is n, n minus 1, n minus 2, so on up to 1 we have. How it is varying? It's decreasing by 1, right? Minus 1, minus 1, minus 1 is happening. So you can observe it is an AP with the first term is equal to n and common difference is equal to minus 1. And what we want kth term, right? So n is equal to k if we consider. What will the term of that? Tk will be equal to, I write as tk. Tk will be equal to what? A plus n minus 1, that is k minus 1 into t, that is minus 1. Okay. So it will be equal to n minus k plus 1. Okay. N minus 1, n minus k plus 1. So I can write here it as n minus k plus 1, right? So this will be the kth term. Fine. Now how to find summation of first n terms? Just consider Sn will be equal to what? Summation from k is equal to 1 to n tk, correct? Sum of the first n terms. If this is the kth term, just vary this k from 1 to n, we will get sum of first n terms. So this is gonna be equal to summation k is equal to 1 to n. Tk is what? K into n minus k plus 1. Fine. Further procedure is easy. Just multiply it and use the property of summation here. Means split that summation and you will get the value of sum of the series. Okay. Further procedure will be what? It must be. So it will be homework question for you. Okay. Further this, whatever. It's very easy. Just split the summation. You will get kn minus summation k is equal to 1 n k plus summation 1 k is equal to 1 to n. Okay. So just try to compute it. You will get the value of sum of the series. Okay. So the remaining, the next part will be what? Homework for you all. So try to do it. Fine. So have you all understood this? Any doubt in this? Let me know. Any doubt in this? YouTube students as well as Zoom, any doubt in this? Okay. Okay. Fine. Okay. So if there is no doubt, then we'll just discuss what are things that we have learned in our today's class, and we'll wrap our class here. Right? So in our today's class, we have seen how to solve the series which are neither AP, GP or HP, as an AGP, but we can make use of the method that is used in AGP. Okay, that series we discussed, and we discussed about the summation. What is summation? Correct? Summation is nothing but sum of the terms. It's a notation used to represent the sum of the terms. And next is what? Next is properties of summation, right? We discussed about the properties of summation. Like we can split the summation. If constant is there, we can take out of the summation. Correct? After that, we discuss some special series which we will make use in finding some other series. Correct? So these are the things that we discussed. We also discussed few problems on that. So in our next class, we'll discuss some more problems and we'll discuss method of difference. Okay? We'll discuss method of difference. Fine? And if time permits, we'll also solve some previous year problems. So this is the content for tomorrow's class. If you don't have any doubt, so we'll wrap our class here and we'll meet in our next class. Okay. Till then, have a nice day and thank you for watching and being so patient. Thank you.